Hello everyone. Today in this video, let us learn about the lab activity, that is the reaction of acids and bases with metals. This is the third chapter in 10th class, acids, bases and salts. So now we'll see the lab activity. It is the reaction of acids and bases with metals. The aim of this activity is, it is the reaction of metals. Here I am taking zinc as the metal with acids, and acids, in that I am taking dilute HCl, and we can test the gas evolved during the reaction between the metal and the acid by using a burning matchstick. This is the aim of our experiment. Now let us see what are the materials required. We have to take a delivery tube, test tube, glass trough, lighted matchstick, that is a burning candle, rubber cork, a stand, some zinc granules, dilute HCl, and then soap water. So these are the materials required for our lab activity. Let us try to conduct the lab activity and see what are the what is the gas that is evolved, and we'll test it by using a burning matchstick. Now let us look at the materials which we are going to use for the lab activity. The first one is the test tube, and this is the delivery tube. This is a trough, glass trough containing soap water. This is the matchstick. Otherwise, you can use a candle also. Here I am taking a burning matchstick for testing the gas which is evolved. This is a rubber cork. This is a stand to which the test tube is to be fixed. Zinc granules. And this is a reagent bottle which is having dilute HCl in it. So these are the materials which we are going to use in our activity. Let us conduct the activity. First, take a stand, and then we have to fix a test tube to the stand. So this is the stand. To this stand, we have to fix a test tube. This is the test tube. So we have to fix it to the stand. Now, to the test tube, you have to add few zinc granules. To this test tube, we are going to add zinc granules. These are the zinc granules which we are putting it in the test tube. Now we have to add dilute HCl to this test tube. Okay, so here I am taking some 10 ml of the dilute HCl. Why? Because see, the first precaution we have to take is that the zinc granules should be dipped in the dilute HCl. So that much amount you can take. Otherwise, you can take a little more also. So not few drops. Okay. So see that the zinc granule should be completely dipped in the dilute HCl. Okay. Yes. So let us add dilute HCl to it. Yes, I have taken a little more. Okay. And now here you are observing that some of the bubbles are coming out. Okay. That means the reaction has started in between the zinc and the HCl. If uh, if the solution is very dilute, that is the HCl solution is very dilute, the reaction will be very slow. If the dilution is not very much, the reaction will be a little bit fast. Okay, so here the concentration of the HCl, how much we have to take is not necessary, but if you just pour some few ml of the dilute HCl to the test tube, if you observe the bubbles coming out of it, then you can continue the activity, otherwise the experiment. Now we have to fix a one hole rubber cork to the test tube. Okay, let us fix the one hole rubber cork to the test tube. This is the rubber cork which is having one hole. Okay, that means one hole will be there, and to that hole we have to fix a delivery tube. Okay, now we'll see in the next slide. Now we'll take a delivery tube and fix one end of the delivery tube to the rubber cork. Okay, let us take a delivery tube. So this is the delivery tube. It is having two ends, and one end of the delivery tube is fixed to the rubber cork. And the precaution now we have to take is that, see that the end of the delivery, that is the first end, this is the first end of the delivery tube, which is fixed to the rubber cork, should not touch dilute HCl. So here it is not touching dilute HCl, it is above it. Okay, so if at all, if it is touching the dilute HCl, the gases will not escape from the delivery tube. Okay, so that's why we have to keep the delivery tube above the dilute HCl. That means it should not touch dilute HCl. This is the delivery tube, and the gases are coming out from the delivery tube. So these are the gas bubbles which are coming out from the delivery tube. And this is a trough, glass trough, which is containing soap water in it. This is the soap water. Okay, and now you have to see that the second end, this is the first end, then this is the second end. The second end of the delivery tube should be placed in such a way that it should be in the glass trough containing soap water. So you have to adjust in that way. First end should not touch the dilute HCl, and the second end should be placed in the trough containing soap water. Now here you are finding the gas bubbles which are coming out of it. Let us test the gas, which gas is coming out of it. Okay, we'll see it in the next slide. So we have observed that the gas bubbles are formed in the test tube, and these gas bubbles, they enter into the trough. Okay, so we have to test the gas bubbles which are coming out from the trough containing soap water. Here we are seeing the gas bubbles. Okay, now we have to test these bubbles. What will happen? So while testing the gas bubbles, we have to be a little bit cautious. So why? Because we are using the lighted matchstick or candle. You can use candle also. So because it is a gas, so you should be a little bit cautious. Now we'll bring the burning matchstick near the gas bubbles and see what happens. See, it puts off with the flame, making a pop sound. Okay, so that means the gas which puts off the flame by making pop sound is hydrogen gas. So that means the gas which is coming out from the trough is hydrogen gas. Okay, now let us come to a conclusion. Let us make a note of our observation. See, we have seen that the gas bubbles are formed in the test tube because of the reaction between zinc and dilute HCl. And these gas bubbles are also uh, coming out from the glass trough containing soap water through the delivery tube. So gas bubbles formed in the test tube, they enter into the delivery tube and pass into the soap solution, and from there you are observing that gas bubbles are evolving. And now we have to test those evolving gases by bringing a lighted matchstick. And so we have seen that the lighted matchstick was put off by making a pop sound whenever it is brought near the evolving gases. Now we can make a conclusion. The gas which puts off the flame by making a pop sound is hydrogen gas. Okay, now we'll write the equation between the reactants and products. Zinc we have taken and dilute HCl we have taken, and you have found that there is a reaction between zinc and HCl giving rise to the hydrogen gas, and the component which is formed, other component which is formed is zinc chloride, ZnCl2. Okay, so this is the gas. So the gas is represented by the arrow upwards. Now we'll see the next. See, we can repeat the activity by taking sodium hydroxide in place of dilute HCl. So we have to make a sodium hydroxide solution, and then we have to take the test tube with the zinc granules, and then you add sodium hydroxide solution to it, and just you warm it, and then you will find that the same gas, that is the hydrogen gas, is evolved in that case also. Okay, so you can repeat the activity by taking sodium hydroxide solution. So we will notice that hydrogen gas is evolved by the reaction between the sodium hydroxide solution and the zinc granules, and the salt formed will be sodium zincate. We'll write the equation. Zinc plus sodium hydroxide gives rise to the salt sodium zincate, Na2ZnO2, and then hydrogen gas. Okay, so from this we can say that, from this activity we can say that metals react with acids and bases, giving rise to hydrogen gas. Okay, so thank you so much.